Hello friends, welcome to C# Intermediate to Advanced tutorial. Now we are at the final part of the video, C# IEquatable interface. So here in this video we are going to override the equals method and we will say how two objects are equal. So in the first video we learned about IEquatable interface. Then we saw what is the limitation of equals method of object. Now in the student class, here we are implementing IEquatable interface. So here we override equals method, which takes an object. We are casting this object to student and we are calling this as that. Then this calling object and we are calling the equals method on the incoming object. So here once again we are calling the equals method and here we defined our equals method which takes student as instance. And here if you see, we just compare only the ID of calling object this and ID of the incoming parameter. Now let's go to the demo and see how it works. We will create a new project. So here we are creating the console application. And we will choose F temp open and we will name it as IEquatable example. So here we have a skeleton. We will create a class and we will call it as a student. So our student class contains 3 members: ID, name, number of days present. So in our program main, we are going to print output on the debug window. So we are importing system.diagnostic package. System.diagnostic namespace. So in the void main, as already discussed in the slide, we are creating 2 instances of student. Then we are assigning student 1 instance to student 3. After that we populate student 1 and student 2. Then we are doing our equals method test. And if you see here, we doesn't override any equals method. That means it will default to student method of the object. Now let's put a breakpoint and explore this. We'll go to watch window. And we will drag and drop each instance of the student. So at this moment, all the 3 student st1, st2, st3 are pointing to nothing. They are null. Now here it represents some heap location and you can see the members are empty at this moment, st2 and st3. Now we are populating st1 members. So you can see here, then st2's member, st1 120, st2 also 120, both are equal. Here content wise, the cells that holds same value, student 1 and student 2. Here we already told st1 and st3 both are pointing to the same location by this assignment. Now here if you look at the test st1, st2 and st2, it is saying they are not equal. Why? Because so if you see here, the content, I mean the address location, this is different address location and the st2 is a different address location. Why? Because here we have two new keyword. That means it creates an object in the heap. So the address location is 11830 for st1 because that is the address st1 is storing here. Here we use the ampersand to retrieve the location, and the next one, if you see, that is holding a different address. But st1, st3 both are holding the same address. Why? Because here we are asking copy the st1 to st3. So st1 address is copied to st3's address. So st1 and st3 both are pointing to the same heap location. st2 is a different heap location which is pointed by only st2. So that's why here when we are comparing st1 and st2, it is saying st1 and st2 are not equal. So the default implementation of object tells these two are not equal because it thinks these two objects are in two different heap locations, so they may not be equal. So in the output window, if you see, it is, since we are doing a debug.writeLine, here you are seeing st1 and st2 are not equal. Now here we are comparing st1 with st3. st1 and st3 both are pointing to the same location. So the equal method of object tells st1 and st3 are equal. So this is the default behavior. Now we will change this by implementing the IEquatable interface here. We'll put two breakpoints on these locations. Now we will run it. So as usual, we are creating two student instance. st3 is pointing to the location of st1, initializing st1, initializing st2. Now this time when you call st1 equals st2, it will go to the overridden version of equals method. So here we have the overridden version of equals method, and it compares this dot id equal to that dot id. So it says st1 and st2 are equal. Next here we are comparing st1 with st3, and if you see, this time we are comparing the content, this dot id, and the passed in objects id. So let's go to the call stack. So this is where we are calling, right? st1 is calling the equals method. So since st1 is calling, here this represents st1. and we are passing st3 as parameter. Here that is coming as a parameter, and we are comparing the id. Here st1, this one is st3. So IDs are equal, so here we are saying both objects are equal. So let's look at the output, and this time it is working fine. Why? Because we overridden the default behavior of object, and we are educating how two object needs to be compared. Here when we are overriding, we provided the override for object as well as a student. So here we are passing the instance of student. Sometimes in terms of inheritance and polymorphism hierarchy, sometimes you may need to pass a base instance reference, and the actual object is pointing to the derived one. So in that time it will follow the route of object, then typecasting it to the required type, and after that it will make a call to this one. Okay, that's all here. Thank you for watching. Bye.